We will be drunk and all of our thumbs went up in the air. Singing in the wind, listen to the thunder rolling over and over we down.
Welcome back. As I promised, we are having Junior Maths Olympiad 008, video 8 on mathematics only. We are looking at binomial expansion 2. We looked at part 1 at the school the other time. I just came back from school now and I just have to produce this because the part 2, this topic is very important. So we have to look at binomial expansion 2. So we have laid the foundation in the school as part 1. So I don't need to go over certain things. I'll just go straight to the question. Question number 1. Find x if 1 plus 8x raised to the power 4 equals to 3 root 3 over 5 raised to the power 8. Well, this one, we don't even need to go into details because if you look at this, the exponent here is 4, the exponent here is 8. You try to make the exponent here the same so I can cancel it because there is a law in indices that say if you have a raised to the power 2 equals to b raised to the power 2, okay? Exponent cancel exponent. So a is equal to what? B. So since you are saying 4 and 8, and you know that 4 is a multiple of what? 8. You try to express this like this. 1 plus 8x raised to the power what? 4. Then equals to 3 root 3 over 5. Now, 8 is 2 times 4. So we have 2 here. Then the after exponent raised to the power 4 because 2 times 4 is 8. Okay, you need to do that so that exponent cancel exponent. So you now have 1 plus 8x equals to 3 root 3 over 5 raised to the power 2, which is 1 plus 8x. The meaning of this is 3 root 3 over 5 times 3 root 3 over 5. This is 1 plus 8x equals to, now, root 3 times root 3 is 3. Root a times root a is a. Root 10 times root 10, so root 3 times root 3 is 3. So 3 times 3 times 3, up here we have 27 over 5 times 5, 25. So this will be 27 over 25. Now you are looking for x. They say you find x because multiply. This will be 25 bracket 1 plus 8x equals to 27. As Olympiad students, smart students you are, open the brackets, it will lead to a linear equation and find the value of x. That is that one. Now, let's go to the one that are a bit more technical than this. Okay? Now, look at this. Please bring the camera closer. This one is from one of the 2022 Olympiad past questions. Determine the coefficient. Just listen to me. Determine the coefficient of x raised to the power 3, y raised to the power 4, z, in the expansion of x plus y squared plus z raised to the power 6. We want to find the coefficient of this. We are looking for the coefficient of this. By the time you expand this, now you remember the topic is binomial expansion. Binomial means 2, but we are having 3 things here, 1, 2, 3. So if you look at this, you try to make 2 of them to become 1. And the easiest one, of course, as you can see, is to pick this one and this, because this one is already having an exponent. So you have x plus z in bracket. Once you put this in bracket, it means 1. Then plus y squared. Oh, sorry, y squared. Everything raised to the power 6. You try to adjust it so that it will be binomial. Binomial means 2. It means you want to see 2 things. And when you put something in bracket like this, it means 1. So this is 1, this is 2. So this is as good as saying a plus b raised to the power 6. Remember, this is what we need to expand. It means that our a is is x plus z, then our b is y squared. Take note of that. Now, you now come here. We need to expand because this one you have to expand it. So you can use Pascal triangle to generate your coefficient. 1, 1, 1. I'm sure you know what I'm doing. 1, 2, 1. 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, this is 5, this is 10, this is 10, this is 5, this is 1. We are going to exponent 6, so we need to do one more. This is 1, 6, 15, 20, 15, 6, and 1. So this is what we need. This is the coefficient. Now, so we use this. So this will be 1 dot A dot B plus 6 dot A dot B plus 15 dot A. Let that plus be big so I can separate it. Dot B plus 20 dot A dot B plus 15 dot A dot B. Okay, I want to clean this. Don't forget that, let me write it here, that our A is x plus z, our B is y squared. So, plus 6 dot A dot B, then the last one, 1 dot A dot B. Now, the highest exponent is 6, so we start with 6 raised to power 6. This will be 0 because the sum must not be more than 6. This will be reducing, this will be increasing. 5, 1, 4, 2, 3, 3, 2, 4, 1, 5, 0, 6. The sum total of the exponent must not be more than 6. Now, you now substitute. This will be 1. Our A is what? X plus Z raised to power 6. B raised to power 0. Our B is y squared raised to power 0 plus 6 into x plus z raised to power, what is this? 5. Then this is y squared raised to power 1 plus 15 dot x plus z raised to power. I will soon stop now. I'll tell you something because we can't keep on. We don't have the time now. Dot y squared plus look at this, plus the next one is 20. Okay, 20 x plus z raised to power 3, then y squared 3. Plus you continue. Now see something. Look at this. Look at what they say to find the coefficient. If you look at this expression, there's a particular one that will give you s y raised to power 4. Do you see it? 2 times 2. Y raised to power 2 times y raised to power, that's y raised to power 4. Can you see that? Yes. If you look at that, can you see that? Yes. So you will pick this. This is what we need. Others will not give you y raised to power 4 because this one is giving y raised to power 2. This one y disappear completely. This one y raised to power 2 raised to power 3, that's 6. So with this one, you will get insight into what you are looking for here. So you will now pick this 15 into x plus z raised to power 4. This is already y raised to power 4. Do you understand that? This is logical. You can't keep on doing it. You have to. There's a particular one they are asking to find the coefficient. And since you have seen y here, so it means that this other one will come out from this. Now, if you look at this one, you will use binomial expansion again. S plus z raised to power 4. You use this one to expand it. This time around, you take x as your A, you take z as your what? B. You will expand it and come and put it here. Then if there's anyone, maybe x is power 3, whatever, until you are able to expand this, then you will now see that some numbers will come up as coefficient of s is power 3. The one that have s, this one, and this. Whatever thing that is that clear? Okay. So just try to think about that while I come forth to the next one, the next question. Now, look at this. Look at the next question, please. Determine the term determine the term independent of x in the expansion of x. Okay, let me just come up with something very simple. In the expansion of maybe 2x plus 1 raised to power 5. Yes, let me come up with something very simple like that. 2x plus 1 raised to power 5. The one that is independent of x, then what you have in mind, that will become complex. I don't want to waste your time. But once you have an idea. Now, if you look at this, you remember the other time I was telling you about using combination method of getting coefficients. So I told you that if you have 5, okay, it means that 5 is the highest exponent combination. Now, which particular term is independent of x that does not have anything x attached to it? Okay? You don't know it, so let it be r. We don't know that particular term. Then the first term here is 2x raised to power that r times. The next one will be 1 raised to power. If this is r, this will be 5 minus r, because this plus this must be equal to 5. Highest is 5. So if this is r, this will be 5 minus r, because the highest must not. Is that clear? Now, this must be equal to the term independent of, determine the term independent of, that term must have a constant and must have s raised to power 0 independent of x. We put it there, okay? S raised to power 0 means s does not appear if we expand it. That's what you are going to use. So the meaning of this is 5 factorial over 5 minus r factorial. Are you following? Then r factorial. This is 2 raised to power. Now split this into 2. 2 s raised to power r means 2 raised to power r times x raised to power r. This exponent multiply this and this. Now this one is 1 raised to power 5 minus r. Now anything raised to power 1 raised to power anything is 1. So that one has gone. So equals to k s raised to power 0. Now, if you look at this, you look at constant, the one that does not have x. If you look at this one does not have x. This one have x. So you compare this one go with this, then this one that have x, you equate them to each other. It means that x raised to power r is equal to s raised to power what? 0. So base cancel base, so that means r is equal to what? 0. Okay, r equals to what? Equals to 0. So you remember that in combination, okay, the r, so that means it is the 0 term. That, okay, it means that there is a 0 term, that means it doesn't exist. So the answer there is none. It's none, because for us to get r is equal to 0. So please, if they say independence of x, just let that term be equal to r, use combination, then you use this to get that solved. Now, let's look at 1 or 2 more questions. We are making progress. Now, there's another aspect to this. If you look at the exponent of what we have been doing, the exponent is positive. If I say 2x plus 3, the exponent is positive, either plus 4 or 3 or 10. What if the exponent is fractional or negative? So please bring me something here. So let's look at an example of that. For example, if I say to expand 1 over 1 plus 2x raised to power 2. Now this one is a different type. Once it is fractional, like maybe 1 over 2 or minus 1 over 2 or minus 2 or minus 3, Then you can't use the method you have been using to solve it. I will teach you the method you are going to use now. So like this one now, law of indices. You try, since this one is 1, you try to carry this up. This is as good as saying 1 plus 2x raised to power minus 2. Law of indices. If I bring it back, it is on to plus 2 up. So if you look at this, the exponent is this. Now for this method, this one, please look at this. Once you have something like this, always ensure that this place is 1. If it is not 1, I will tell you what we do. But luckily for us, it is 1. So you make it as 1 plus a raised to power minus n. You make this other one to be a. Now this one has a formula. The formula is you start with 1. You start with 1 plus n a over 2 factorial. This one is over 1 factorial. We don't normally put it there. Plus, now it will be reducing. This n will be n into n minus 2. Then this a will now become a squared over 3 factorial. You continue like that. Now for something like this, after you might have done 1, 2, 3, you stop. But continue. The next one will be n times n minus 2 times n minus 3. This will become what? A raised to power 3 over what? 4 factorial. So usually for this one, this is the method. Look at the formula. So make sure that this place is 1. What if this place is not 1? I will tell you in another place. So once you do this one, very simple. You just substitute now. Your n is minus 2. Your a is 2x. And you know the meaning of, so you just substitute and find this. Now, let's assume that we have something like this. So you substitute there and find the answer. That's all. That one is straightforward. Now, let's look at this. Let's say I give you something like this. Expand 2 over square root of 1 minus 2x. Now, the meaning of this in mathematics is 2 over 1 minus 2x raised to power half. Do you agree with that? Square root. If it is cube root, 1 over 3. If it is this one squared, cube root, it will be 2 over 3. But this is square root, that's it. Now the meaning of this is 2. You will carry this up like this. It will become 1 minus 2x raised to power. This will come to minus half. You see now? Now, this one will become 2. Always make this place plus, so that this one will separate like this, so that you don't make mistake. Then, everything is for minus half. So in this case, your n exponent is minus half. Your a is minus 2x. Because this will become 2 into 1 plus a raised to power minus half. Is that not so? This place must always be 1. If it is not 1, I will tell you later what we'll do very soon. So this will be 2. So this one, you don't have any problem with this one. So it's this one that you are going to use binomial expansion. Once the exponent is not positive, once it's fractional or negative, you will use 1 plus na over 2 factorial plus n. It will reduce into n minus 1. Then it will become a squared over 3 factorial plus, once you do 3, don't forget, stop, because you keep on reducing, it will keep on becoming insignificant. So 1, 2, 3, in fact sometimes 1, 2 is okay. So simple. You expand this, whatever thing you get here, you now multiply everything by 2. Now this one, our n is this, our a is minus 2x. You put it there and carefully substitute it and get the answer. Okay. Now, look at what I'm talking about now. What if it is something like this? What if it is something like this? For example, now, you can be asked to solve this without using calculator. Solve this 2.005 raised to power 8. Raised to power 8. Okay? Now, if you look at this, You cannot say 2.005 times this in 8 places. It will waste your time. Do you understand? It will waste your time. So what you do here is that you try to adjust this as this 2 plus 0.005 raised to power 8. Sometimes this can just be half. It can be half, square root of this. Okay, let me use half so that it will conform to what I'm doing. It can be 8. You will still use this formula. Now, I told you that you have to make this place 1. So you bring out 2. This place will turn to 1. Then it means that this place will be 0.005 divided by 2. Okay? Raised to power half. See that? When you bring out 2, now this 2 is initially inside this bracket. That means this place will also be raised to power half. Do you understand that? Yes. I brought out this 2 out. Initially this 2 is inside this square root, inside this bracket, and that's this exponent. So it must have this exponent. Now our target now is this. So it will now be 2 raised to power half into 1 plus a raised to power. You use 1 plus n-a over 2 factorial. Now this one, by the time you do 1, 2, for this you stop. All this other one is insignificant, please. So this is square root of 2, that's the meaning of 2 raised to power half, into 1 plus, what is n? N is half. A is this. So that will be half times 0.005 over 2. Okay, that's our A, divided by 2 factorial is 2. So that is all. So that will be with 2 into 1 plus, all these 2 will go down. That will be 8. That will be 0.005 divided by 8. All this one. Okay? 0.005 divided by 8. All these two will go down to make this become 8. Then you now do it and then you get your answer. I think I will stop there, okay, for you. I wish you all the best in your exam. If you still have time, I still have 1 or 2 things, but if not, too, we have done our best. Thank you very much. Bye.